Water heating systems. The reference for this section is the reference appendices section RA 3.6. As always, that's the link to find the document on the CEC website, and it's also available for download on the LMS system. HERS Field Verification offers credits for improved performance in terms of quality pipe insulation installation, for the installation of field-verified hot water distribution systems that are more compact and therefore perform better than typical hot water distribution systems, and for the installation of specific circulation strategies. The overall training goal for this section is to familiarize yourself with water heating systems verification protocols and forms. These are all the sections and water heating related credits that we'll be covering in this PowerPoint. So first we're going to be covering the HERS pipe insulation mandatory requirements. It's required for hot water distribution systems where the insulation shall fit tightly to the pipe and all elbows and teeth shall be fully insulated, as shown in the pictures. No piping should be visible due to insulation voids, with the exception of the last segment of piping that penetrates walls and delivers hot water to the sink, appliances, etc. Insulation is to be present on the first 5 feet of hot and cold water piping from storage water heaters. All piping from the water heater to the kitchen sinks and dishwashers have to be insulated. Also, all non-recirculating hot water piping of 3/4 of an inch diameter or greater. All hot water piping below grade has to be insulated. Also, all piping below grade must be installed in a waterproof and non-crushable casing or sleeve that allows for installation, removal, and replacement of the enclosed pipe and installation. Piping below grade that serves any islands, sinks, or other island fixtures or appliance may be insulated with 1/2 inch wall thickness insulation. Now there are exceptions. Pipe insulation may be omitted where hot water distribution piping is in attics, meaning it's completely surrounded with at least 1 inch of insulation. Piping must be elevated from the framing, and piping is completely covered with at least 4 inches of insulation further away from the conditioned space, or in walls when it's completely surrounded with at least 1 inch of insulation. So in these particular scenarios, the mandatory piping requirements that we just described in the previous slides don't have to apply if the conditions in this particular slide apply, because basically the pipe will be already wrapped in insulation without any additional insulation be added to them. Now let's cover the procedures to actually verify HERS credits related to water heating.
So let's start with the pipe insulation credit. So this is a visual verification, visual inspection, and what you're going to do is you're simply going to verify that all hot water piping is insulated. And now this credit is only available for trunk and branch hot water distribution systems. The hot water piping from the water heater or heaters to all fixtures and appliances shall be insulated based on the values found in table 120.3-A, which is usually 1 inch of insulation, or R7.7. So the HERS rater shall verify that all hot water piping is insulated in accordance with the mandatory requirements that we previously described. And that was, all of it's going to be covered in the insulation, including bins and all sections within the walls, the exceptions for if it's an exterior wall that's already insulated, maybe it doesn't need it because it can be have 1 inch of insulation around it. So all those requirements we discussed are what's going to apply to this particular inspection. And here is table 120.3-A. So if we look at this table, this gives various ranges of temperature that's going to be moving through various pipes, as well as pipe diameters, and then the required R value or inches of insulation. So because we are dealing with domestic hot water, that's going to be in a range of, it's going to be an average of about 120 degrees. That's the recommended temperature. So if we look on the chart in the very first column on the left there, we're going to want to go all the way down to that bottom where it's 105 to 140. All of these DHW systems should fall within that range. And so if we move over to the right, where we're looking at our nominal pipe diameters, the first column there is less than 1 inch, which again, most residential systems are going to be less than 1 inch for those distribution pipes. So we can see our inches is 1 inch, or an R value of R7.7.
For central parallel piping or home run system, this measure expands on the requirement for parallel piping systems that use one or more central manifolds with individual runs from the manifold to each point of use. Visual inspection shall verify that all supply lines of the parallel piping system meet the following requirements. The maximum measured length of pipe from the water heater to each central manifold shall not exceed 5 feet. That's measured to the nearest half foot. The hot water distribution system piping from the manifold to the fixtures and appliance must take the most direct path. For example, in a house with more than one story and the water heater in the garage, this requirement would exclude running hot water supply piping from the manifold to the attic and then running the line back down to a first floor point of use. The lines have to be the most direct, shortest as possible.
The hot water distribution piping must be separated by at least 2 inches from any other hot water supply piping and at least 6 inches from any cold water supply piping. And this to prevent any of that heat transfer either from a hot water line to another hot water line that may not be as hot, or from hot to cold, which would be even worse. So the HERS rater shall verify that all hot water piping is insulated in accordance with the mandatory requirements previously described. And so you're going to look at that table that we looked at, but again, it's most likely going to be 1 inch or R7.7. Now let's look at the compact hot water distribution system expanded credit. Now there is a basic credit that is not HERS verified, and then there is the expanded credit, which is HERS verified. So in order to meet the compact hot water distribution system expanded credit eligibility requirements, the requirements for the compact hot water distribution credit must be met. So you have to first meet the requirements of the basic before you can take credit for the expanded credit. So in addition to meeting all the requirements of the basic credit, the following HERS field verifications are required. So you will field verify that no hot water piping larger than 1 inch in diameter is present. Any length of 1 inch diameter piping is limited to 8 feet or less. So you can have 1 inch diameter piping, you just can't have larger than 1 inch. For 2 and 3 story buildings, you cannot have hot water distribution piping in the attic unless the water heater is also located in the attic. And eligible recirculating systems must be HERS verified demand recirculation with a manual control system. So this is what you're going to be doing as part as the HERS field verification for the expanded credit is you're going to look for these items, you're going to visually verify these items, and then the only prerequisite, which is going to require additional inspections that we'll talk about here shortly, is that they must take credit for the HERS verified demand recirculating system, and it has to be a manual control.
Recirculation systems are not eligible for the pipe installation credit, but HERS verification of pipe installation is a mandatory requirement. For systems serving a single dwelling unit, the recirculating loop within a dwelling unit must be laid out to pass within 8 feet of each hot water fixture served by the loop. These inspections may require 2 visits, a rough and after all equipment is set and operational.
Demand-controlled recirculation systems shall operate on demand, meaning that pump operation shall be initiated shortly prior to the hot water draw. The control shall operate on the principle of shutting off the pump when a sensed rise in pipe temperature, or delta T. For this HERS verification process, a manual switch is required. So essentially the way this works is you're going to have 3 pieces to the system. You're going to have a pump, you're going to have a thermal control, and you're going to have a manual button or switch. So when a homeowner wants to utilize a fixture at a sink, for example, and they want to use the hot water, instead of turning on the hot water valve and letting it run and run and run until all the cold water's been replaced or evacuated from the line and it's now bringing in hot water, they'll press a button or flip a switch, and that'll turn on the pump. The pump will then run and pump hot water through that line, so that when they do turn on the fixture, it's a very short period of time before hot water starts coming out, so it helps stay with water savings. And then you have this thermal switch that will sense that the hot water has made its way all the way through the recirculating loop, and the pump is no longer needed, so it will then automatically turn that pump off. So there may be more than one circulation loop, so you're not limited to one. That's the most common, is have just a single loop. But if you're in a very large house and you have multiple water heaters, you may have multiple loops present within the house. Each loop must have its own pump and controls, and then you will be verifying that the pump, demand controls, and thermosensor are present. So the pump and the thermosensor are generally going to be located very close to the water heater. The thermal controls or the demand controls themselves are going to be located throughout the home at various places, and we'll look at where they're required. So part of your inspection is to go through and make sure that these items are installed. And we can see in the pictures here at the top, that's a typical pump with a timer control associated with it. Oftentimes down in the lower left-hand corner, those are our thermosensors, and oftentimes those will be connected directly to the pump, so they're very easy to kind of trace and find where it's at. And then you have a different type of control over there that allows actually the water to flow through it, and it will open or close the valve based on those demands. So those manual switches or demand controls shall be located in the kitchen, all bathrooms, and any hot water use location that is at least 20 feet, and this is measured along the hot water piping from the water heater. So in the pictures here is just an example. This is kind of a push button demand control. There's going to be different types. Oftentimes they are going to be some kind of push button control, because it's not a turn on and turn off. You just want something that's going to initiate the start of the pump. And so these are what you're going to be looking for in these various locations as part of your inspection.
Manual control systems may be activated by wired or wireless button mechanisms. Verify that manual controls have a standby power of 1 watt or less.
You will need to verify that pump and control placement for the demand recirculation system meets one of the following criteria. When a dedicated return line has been installed, the pump, controls, and thermosensor are installed at the end of the supply portion of the recirculating loop, or the pump and controls are installed on the return line near the water heater, and the thermosensor is installed in an accessible location as close to the end of the supply portion of the recirculation loop as possible. Or last, when the cold water line is used as the return, the pump, demand controls, and thermosensor shall be installed in an accessible location at the end of the supply portion of the hot water distribution line.
You will then verify that a check valve is installed in the recirculation loop to prevent unintentional circulation of the water, also called thermosiphoning, and backflow when the system is not operating. This check valve may be included with the pump.
The HERS rater shall verify that the supply portion of each circulation loop, the first 5 feet of branches off the loop, and the dedicated return line are insulated according to the values listed on table 120.3-A. And again, that's the table that we previously looked at in the pipe insulation section. Insulation is not required on the cold water line when it is used as the return, and all other hot water piping is insulated in accordance with the mandatory requirements that we previously described.
The hot water distribution system piping from the water heater to the fixtures and appliances must take the most direct path. And again, for example, in a house with more than one story and the water heater in the garage, this requirement would exclude running hot water supply piping from the manifold to the attic and then running the line back down to a first floor point of use. just like we talked about in other distribution systems. You also need to verify that manual controls initiate pump operation by pressing one of the manual controls and observing that the pump turns on and then shuts off in accordance with one of the two methods listed. After the pump has been activated, the control shall allow the pump to operate until the water temperature at the thermosensor rises not more than 10 Fahrenheit, 5.6 degrees Celsius, above the initial temperature of the water of the pipe, or the control shall not allow the pump to operate when the temperature of the pipe exceeds 102 Fahrenheit or 38.9 degrees Celsius. You will then want to verify the controls have a feature that limits pump operation to a maximum of 5 minutes following any activation. This is provided in the event that the normal means of shutting off the pump have failed. The manufacturer of the recirculation pump and the control shall provide installation and operation instruction that provide detail of the operation of the pump and controls, and such instructions shall be available at the job site for inspection. You will need to verify for this information to be present at the job site. For demand recirculation sensor control, the requirements for this credit are the same as the ones previously described for manual controls. A sensor control, such as motion sensor, door, and floor switches, are used to activate the pump rather than a manual control. For multiple recirculation loop design for domestic hot water systems serving multiple dwelling units, the visual inspection shall verify that a central domestic hot water system serving a building with more than 8 dwelling units has at least 2 recirculation loops, each serving roughly the same number of dwellings. Unique building sections may have additional recirculation loops. These recirculation loops may be connected to the same water heating equipment or be connected to independent water heating equipment. Ideally, each loop will have its own pump and controls.
Drain water heat recovery system. So drain water heat recovery, or DWHR, is a technology that captures shower waste heat from the drain line. DWHR devices are counterflow heat exchangers with cold water entering the building on one side of the device and hot drain water exiting the building on the other. A DHWR device uses that reclaimed heat to preheat potable water that is then delivered either to the shower or to the water heater. The device can be installed in either an equal flow configuration or an unequal flow configuration. Equal flow means that the preheated water being routed to both the water heater and the shower. An unequal flow is where the preheated water is directed to either the water heater or the shower. So those are the two options that we have. The energy harvested from a DWHR device is maximized in an equal flow configuration. So we want that preheated water going to both the water heater as well as the water going into the shower. They are sold in both vertical design configurations and in horizontal configurations. And so here we have 3 examples, one of the equal flow and then the 2 options for the unequal flow where it goes either to either the water heater or to the shower itself. So the picture on the left hand side there, that is our equal flow. So you can see the gray line is the water that's leaving the shower. So hot water, you use it, it starts going down the drain. That water's going to be warm or hot. It's going to pass through this heat exchanger and then go out to the sewer system as normal. The blue line is then the cold water coming in from outside the house. It's trying to make its way to the water heater, and so this cold water is going to pass through this heat exchanger, and it's going to be preheated by the waste heat that's flowing out from the other side. So you're going to get that exchange of heat from the drain water into the fresh supply. Now these are not mixing; they're just going on opposite sides of this heat exchanger. So in the equal flow, we're going to get that cold water, or that preheated cold water is going to go into both the water heater, which is going to make the water heater work less because the water is going to be a little bit warmer going in, which means that it requires less energy to heat that water up. And then as well, it's going to be going up to the shower. So instead of being able to turn on just the cold water and having really cold water come out, it's going to be preheated as well. So you're going to need less hot water from the water heater to get the same temperature within that shower. Now the one in the middle there, same concept. You have your gray line, which is your drain going out, passing through the heat exchanger. And now in this one, we have two cold water lines. The cold water line will split off, and one of the runs will go through the heat exchanger, get preheated, and go into the water heater, which does help because now the water heater doesn't have to work quite as hard to heat up the water, but it's going to be sending cold water up to that shower. So we're still going to need just as much hot water to get the same temperature as if we had no DWHR system installed. So it makes the water heater a little more efficient, but you're still needing to use just as much hot water to get that same temperature. And then the one on the right hand side there, same basic layout. Again, you have two cold water lines coming in. One of those cold water lines is going right to that water heater, dumping cold water into it, so it's going to have to work just like a regular water heater to heat that water up to get it the temperature that you need. But at the shower itself, you're now getting preheated water with the hot water from the shower, so you don't need as much of that hot water from the water heater to get the desired temperature. So they each have their benefits, but again, as you can see, you'll get the most benefit out of that equal flow system. So for your inspection, you will need to verify the following requirements. The make, model, and CSA B55.1 or IAPMO IGC 346-2017 rated effectiveness of the DWHR unit, and these will need to match the compliance documents. So again, when they do the performance modeling, they're going to create that CF1R perf, and that is going to have the required effectiveness rates listed on there, so you need to make sure that those match up, and then you're going to get the make and model numbers so that you can confirm that those are the values that are associated with it. Next, the DWHR units shall also be verified as a model certified to the Energy Commission as qualified for credit as a DWHR unit. And this is, they will keep a list of all of the approved models, and you'll just need to look on that list to verify that it is that this particular make and model of unit is present on that list. And then the installation configuration and the percent of served shower fixtures shall match the compliance documents. So again, it's either that equal flow or unequal flow, and then depending on how many showers are on the home, they may take credit for installing one of these on just a single shower or in multiple showers. If they have 3 bathrooms and each bathroom has a shower, then they may take credit for these devices on all 3 of those showers. So you need to make sure that it matches the configuration and the number of shower fixtures that need to have that device installed. For a water heating system serving a single dwelling, the DWHR system shall, at minimum, recover heat from the master bathroom shower and must at least transfer that heat either back to all the respective showers or the water heater. So that would be an unequal flow. So that's the minimum, is to have that unequal flow. For a central water heating system serving multiple dwellings, the DWHR system shall, at the minimum, recover heat from half the showers located above the first floor and must at least transfer that heat either back to all the respective showers or the water heater. So again, the minimums for these, whether it's single dwelling or a central water heating system on multiple dwellings, is the unequal flow method, and you're going to be transferring that heat either to the other respective showers in the home for single, or at least half of them in a multifamily scenario, or just back to that water heater. The DWHR unit shall be installed within 1 degree of the rated slope. Slopes DWHR shall have a minimum lengthwise slope of 1 degree, and the lateral level tolerance shall be within plus or minus 1 degree. So these devices are intended to be installed with some slope so that the water will drain through it at a steady rate. And that rate is how they calculate how efficient that unit's going to be. If it's got too much slope on it, that hot water is going to flow through it too quickly, and you're not going to get enough heat transfer through it for it to meet its rated effectiveness. So what you're going to need to have a digital level so that you can go up there and you can check that it is installed within 1 degree of the rated slope, and that would be the manufacturer will provide that, so you can get that information from the installing contractor. And so you're going to check that to make sure. And so you have a plus or minus 1 degree tolerance that is allowed. So let's say it's supposed to be installed at 3 degrees. If it's between 2 and 4 degrees, then that would be acceptable.
Now we'll be covering the form specific to HERS inspections related to water heating systems.
The CF3R PLB 21A is for multifamily central hot water distribution systems, where the CF3R PLB 21B is for multifamily central hot water distribution systems that utilize an NEEA rated heat pump water heater. The CF3R PLB 22A is for single dwelling unit hot water distribution systems. And the CF3R PLB 22B is for single dwelling unit hot water distribution systems that utilize the NEEA rated heat pump water heater.
And if you have any questions, give us a call, shoot us an email, or contact us through the messaging system in the LMS.